Welcome viewers. In today's lecture, we are going to learn the first segment of plane wave. Plane wave is a wave whose phase is constant over a set of planes. In case of uniform plane wave, the magnitude and the phase of the wave both are constant over a set of planes. Uniform plane wave will travel in the direction of propagation. In the picture, we can see the direction of propagation of the plane wave. The uniform plane wave will travel in the z direction. The field that is passing through the successive wave fronts have no dependency to the x and y axis. The nature of plane wave will be transverse. These are called TEM waves. If we consider the electromagnetic waves, this is nothing but typical uniform plane waves. The stored energy which is transmitted is equally divided into two fields. Uniform plane wave has no variation of intensity in a plane x, y. Those are normal to the direction of propagation z. Let's consider an electric field whose direction is in the x direction. The electric field is constant in xy plane. The field therefore is given as E vector open bracket x, y, z, t close bracket is equal to Ex open bracket z close bracket e to the power j omega t x hat. Let us consider the wave equations. Grad 2 E is equal to mu epsilon del 2 del x squared E. Substituting the above equation into the wave equation, del x is equal to del y, which is equal to 0, because the wave is travelled along the z direction. The wave that is travelled along the z direction is d2 dz squared Ex open bracket z close bracket is equal to minus omega square mu epsilon Ex open bracket z close bracket, which is equal to gamma square Ex open bracket z close bracket. Ex is the function of z only, so the partial derivative is considered a full derivative. We are familiar with a term called the propagation constant. As we know that gamma is equal to alpha plus j beta, we can replace the value of gamma here. So, gamma square is equal to minus omega square mu epsilon, which is gamma is equal to j omega root over mu epsilon, which is j beta. The phase constant beta of the medium can be considered as omega root over mu epsilon and the attenuation constant 0. A travelling wave which is travelling in z direction and minus z direction can be written as Ex is equal to Ex plus e to the power minus j beta z plus Ex minus e to the power minus j beta z. As we know from the Maxwell's equation that change in electric field will produce the magnetic field, which is Carl E vector is equal to minus mu del t of H vector. Substituting the Ex from equation 1 into the Maxwell's equation, Carl cross E is equal to minus j omega mu H vector, which in matrix we get x hat, y hat, z hat, 0, 0, del z, Ex 0, 0 is equal to minus j omega mu H vector. If we solve this determinant, we will get del z of Ex y hat is equal to minus j omega mu H, which is equal to minus j omega mu open bracket hx x hat plus hy y hat plus hz z hat. After solving the determinant form, we have components only in the direction of unit vector of y. So we are getting minus j beta ex plus e to the power minus j beta z plus j beta ex minus e to the power j beta z, which is equal to minus j omega mu hy. Hy is equal to beta by omega mu ex plus e to the power minus j beta z minus beta by omega mu ex minus e to the power j beta z. The magnetic field H has y direction component only. The traveling wave travels in plus z direction and minus z direction. The traveling wave has the amplitude beta by omega mu e plus and beta by omega mu e minus. The electric field and the magnetic field for the traveling wave in the plus z direction would be Ex by Hy is equal to E plus by beta by omega mu E plus, which is equal to omega mu by beta. The traveling wave in the minus z direction would be Ex by Hy is equal to E minus by beta by omega mu E minus equals to minus omega mu by beta. The unit of Ex is volts per meter and the unit of Hy is amp per meter. So, the unit of Ex by Hy is volt per amp. Substituting the values of beta from equation, j omega root over mu epsilon is equal to j beta. Putting the value of beta in Ex by Hy is E plus by beta by omega mu E plus, which is equal to omega mu by beta. We are getting eta is equal to omega mu by beta is equal to omega mu by omega root over mu epsilon is equal to whole root over mu by epsilon. The eta is the intrinsic impedance. It is the property of the medium. It serves the same role as the characteristics impedance in the transmission lines. So, in today's lecture, we have learned plane wave, uniform plane wave, wave front, traveling wave equation, intrinsic impedance. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, practice and learn. Thank you and goodbye.